Today we are going to see modules in Python. Is my screen visible where I have my main package opened?
Yes.
Okay. So we will see some example module. So we always have user defined and inbuilt, right? We have inbuilt function like print, and we can create our user defined function. We have inbuilt class, and we can create our own class and we can use it, right? Similarly, I'll show an example. So there is a function. So there is a method called seal. It belongs to class math. So that is why we use math.seal. It is to find the ceiling limit of a number. It will round a number to a ceiling, to a next upper value. Okay. So when I run this, it's telling math is not defined because we have to import the library. Otherwise, it will not know where this math is. So if you import the library, it knows it is inside this folder called math, and then it will now execute fine. It will give me 3. So similarly, we have many other important functions which are inside some library. So we have to import that library. We have to tell which folder that particular function is or method is, like how we have a class, something similar to it. And then we can execute it fine. Okay. So here we have a director method function. So director function will tell what all is there inside this library math. Here you see it has all these methods inside math. We can make use of it, but we need not learn all the libraries, all the methods in Python. It will, like, we have lakhs of methods and library inside it. We need not learn all them. We need only what is important to us, what we use frequently and regularly, right? So most of the regularly and frequently used functions are covered in our courses. So if we become very comfortable with those functions, we are good. We are good to write any Python function. So here, this this example is to show that you have something inside this folder. You wanted to use it. You have to import it. Import is a keyword in Python. You use it to tell where that particular folder. If you are importing this particular folder, and inside that folder we have this. Okay. Similarly, we will see what is module. This is all. Now, what we're going to see is user defined, not the inbuilt one. In real world, we will not have like one single file, Python file, which will do everything. We will have folders and we will have many subfolders, and we'll have multiple Python files which will be calling each other. Okay. So as I said, we had this Amazon example, right? Some person is taking care of order, some person is taking care of homepage, but still there will be communication between order and the homepage. So this Python might call that Python, which is already created by some developer. So let's assume this is my main package. I have a folder. I gave some name, my main package or anything. Okay. And inside that folder, I have one more subfolder and I have named it as sub package. Okay. And I have one file here, subscript, and here I have one file called main script. So the main package is having two items. One is sub package, another is a main script, and sub package is having subscript inside it. Okay, these are all the files we have. We have totally two files. One is subscript, another is main script. And you see, there is a file called underscore underscore init underscore underscore. Like we have this method in class, right? We have one default method in class. We will have dunder method underscore underscore. Similarly, we have a file inside each folder. Inside the main folder, we have underscore underscore. Inside the sub package also, we have underscore underscore. So this is to tell that you are inside a folder. You should have it. Whenever you create a directory uh, and you mark it as a package name, then you create underscore underscore Python, which is must inside all the folder. Okay, it need not have anything. It is actually empty here. Let me open it. So it is underscore underscore init is empty here, which is inside the main package. Let me open the sub package as well. Here we are inside main package and then sub package. We have init.py, which is also empty. Okay, but we should have that one Python file with this name. Okay, each module should have it. Now let open subscript and see. Inside the main script, we this inside the main package, we have a file called main script, right? It just has one method, one function called main report. I'm just printing that I'm inside the main package. I am in main script inside the main package. Okay. And let me open the other one. What is there in the sub package? So here I have a method called sub report, and I'm telling just printing a line function inside the subscript. Okay. Just we have a print function inside each file. So module is, we have two concept here. One is module, another is package. Okay. Module and package concept is to call one Python code from a different Python code. Okay. Module is nothing but a .py file, the file what you have here. It is nothing but a module. To create a module of your own, you simply create a .py file with a name. Okay, you can give any name, and then you have to import it in another file using import command. Okay, we will see that example. And we have another concept called package. Package is nothing but a directory. So this main package is a directory. It's a folder. Inside that we have many items. So this is a package, and a file inside the package is called Python file is called module. Okay. Each package in Python is a directory which must contain underscore underscore init and uh, any Python file you want to have. Okay. It can be empty, but it's just an indication that you are inside a directory. This file can be empty, but you're just telling that you are inside some directory. Directory is nothing but a folder, a package. Okay. So Now, so we have this main package, but now from the outside, I want to call the function inside this main package, like how we do. Like we are outside this math, we are nowhere inside this math, but somewhere from outside you are still trying to access what is there inside the math. Similarly, we will see with a user defined example. Okay, I have written this program. Let me open one Jupyter notebook inside this path, my project Python. Okay. Okay. So inside this project Python, we have my program and we have my main package as well, right? So let's see an example. So here I wanted to use from the my program, I wanted to use main report and sub report, all this method. Okay, whatever we have seen here, main report, and here we have sub report. I want to use it. So let's see how I'm using it here. So what I'm telling, from main package and inside the script, main script, import this method, main underscore report, this function. Okay, so let's see here. So for example, inside this main script, we are inside main package, and then inside main package, there is a file called main script, and inside it we have main report. Okay, so how are we mentioning it? We are telling this is a package and this is a module. Module is nothing but a Python file. So we are telling using dot, we are telling inside this package we have inside this module, and inside that module, I want to use this function, okay, main report, import that function. Similarly, I'm telling inside this package, I have another sub package, and inside that, there is a function, there is a Python file module called subscript. And inside that subscript, since I could only here, I was importing a method directly. Here, I'm just importing a file. There is a difference, right? I can I can give like this as well. Dot subscript import sub report. Okay, I can give like this as well. If I give like this, I can directly use sub report. Okay, but in the statement line number 2, I'm just importing a module. Only tell module we are importing. We are not telling what function we want to import. So that is why whenever you call a function, you are telling inside this module, because Python now knows only till here. Okay, then I'm telling inside this module, there is a function sub report. It belongs to this subscript. I want to execute it. If you directly imported it, it will know that this is a function. You can directly use that function. So when I call this, it is printing I'm in a main script in main package. When I call this, it is telling I'm a function inside subscript. Since we are printing it twice, that we see the two output. Guys, is it clear or is it confusing? You want me to explain something here? Amit, Arlene?
No, no, I think I'm getting it. So in the third line, so
Mm-hmm.
that means specifically we need to know all the function and everything, right?
Yeah, yeah. So
And
here, this is
let's
a
say if there
user
are,
created, right?
uh,
Uh,
yeah,
this is user created. You only created. You want to import it in your another function or create, for example, it is created by your team member, maybe Maldi had created all this. So now you have access to that repo, right? You can open and see, you know where it exactly is. So you know the path and you are importing it here.
if there are multiple, then we need to call each and every one
Yeah.
one by
So
one.
for
So
example, imagine the main script as having main script is having multiple function. Okay. Then in that case, you need not import a method directly, sorry, a function directly. So
mhm,
here I'm importing a function, right? You need not do it. You just have to import like here how we are doing. Only the file you import, then any method inside the file you can use it like this. You just have to give this Python file and this method, this function. Okay. But all the modules you have to import. This is a module, right? This is a Python file. All the Python file, whichever you wanted to use. If you are going to use hmm, functions of three different Python file, then you have to import all three file here. But if you feel that you're not going to, if you feel that you're going to use multiple method of a single file, there are multiple other method. For example, the subscript is having 5 method and you want to use all 5, then just import the file and use it here like this instead of this is to avoid multiple import command. So when you import this, it is loaded into your when you run this particular file is loaded and it knows what all the method it has. You just have to call it by the name, the file name and the method.
thanks.
But yeah, if you have to call three Python file, you have to import all three Python file. I'll comment all this. Now I will try to call this main report sub report. Since it's loaded, maybe it's showing. Okay, since it's already loaded here, it's showing. But if I haven't done this, right? First time when I call like this, it will not know where this main report is. It will throw me an error. Maybe we can reload this. Let's see. Let me execute this directly. Okay, it's still working. The reload is not helping me. But yeah, if I haven't run this and we are just calling this, it will not work. It will not know where the main report is. So it will throw us an error. Like how we saw here. Mm, like before importing this math, we were seeing some error, right? Then after importing math, you are able to run this successfully. Similarly, it would work the same way here. Without input, it will not work. Clear? Shall we move on to next topic?
This from keyword, we are using this from
From
keyword, right?
yeah, both. So here in this example, the user defined one, we are just directly importing the method. No, the class. Okay. So object or class. So here we are directly importing it, and we are using that, or it is a module. It can be a Python file. I really do not know how it is defined, created in Python. Import is always to import a module, and from is to import a package. Here we are importing the folders, and later import from, we usually use it to import a package or the module. Okay, import is also used to import a module or a function. Here we are importing a module, which is nothing but, sorry, here we are importing a function in a module. Inside this module, we are importing a function. Here we are importing a module itself, a Python file. Here again, we are importing a function inside a module, subscript. So it is just for the clear understanding. We are making it like this. From this package, I'm just importing this particular method or file, so that anybody who reads your file will understand. I can run in this way also. Let me show that. Import to this particular line, like from main package, sub package, import the subscript. I can do it like this also. I can tell the main folder name, subfolder. I can start from the main to the lowest one, like a module or a function. I can give a function name also here.
So if you are giving only import my main package, so this will not understand that where this my main report will
It will
be.
understand. It will understand. Both will work the same way. Even here, import, I'm telling my main package, and inside that my main script, there is a file, and inside that I have a function. This also will work similar to what we have here, but in real time. So import will, using import only you can achieve. You can give from the main folder to the function, the last function, whatever you want to import. But in as a regular practice, this is how we use in real world. We take from, so that we are telling this is a package or folder, and then we import. Either will work, but you shouldn't get confused when you see from in the real world. When somebody is writing from, you shouldn't get confused. Both will work similar.
Okay.
Yeah, sorry, ma'am. I got disconnected in between. So,
Mhm.
what is the difference between import and from? So, import is to refer that particular function, and what about from?
From, it will tell you which package you are loading from. It is not necessary that you should always use from. So this line is equivalent to this line. Using just
Okay.
import only, I can do the same thing. I'm telling the main folder, subfolder. Sorry, this is a file here. Main folder, and inside that we have this file, and this file has this function. I can either do this or I can do this as well.
Okay. So,
Here,
it is
I'm
the
just
same
telling the
function.
main folder. Yeah, same. I'm telling a file name, and here I'm directly importing the method. Both will work fine, but this will be easier for us to write. But in real world, you will see many developers are writing this way from.
Okay, and this package should be present in the same library, right? Same
Yeah,
folder.
same level. Like for example, where is main packages in the same path only. I have this file, for example. So I have a main package, right, which is inside desktop project Python. Inside the same folder only, I have my program.
Okay.
If I'm one step before, like if I'm inside desktop, right, then I have to import this project Python as well. If at all it is a Python package. If it is a Python package, then it should have underscore underscore in it. That file should be present. Okay, otherwise it will not work.
Okay.
Clear, Amit? Clear, Maldi? Arlene?
Yes.
Okay.
Yes, ma'am.
So now we will see error and exception handling in Python. Okay. So when I ran this, now we got a syntax error. Syntactically, whatever we have written is wrong. The description is also specifying way we have to fix it. It is telling unterminated string. So the string should be terminated. If you are telling it is starting here, you
Single
also should
quotes.
tell it is
Single
ending here.
quotes. Yeah.
Yeah, single quotes. You have to tell it is ending here, right? So this is a description Python tells when you miss your single quote. Like you are not telling where it is ending. So this type of error name, this is a description, right? This type of error and description is called exception in Python. Okay.
And do we have try catch option here?
Yeah, we
Like,
have, we have, yeah, yeah.
yes. Okay.
So this is called exception when you have a error name and also you have a description for that error, then that is called exception. Okay. This is a inbuilt exception. This is a inbuilt function. When you write, Python will tell. Similarly, when you have your own function, you have to tell when something goes wrong. We will not know where it might go wrong. Okay, but if something goes wrong, we have to tell some meaningful uh, error name and the description. We have to give an exception. So this is called uh, exception handling. So whenever you face a error during execution, when I run this only, it will tell me that error, right? During execution, whenever you face any error, you detect any error, it's called exceptions. Okay. So let's see. So here in real world, in inbuilt way, we have two kinds of error. One is semantic error, another is syntax error. Okay, we will see what is the difference between semantic and syntax. Okay, so here this is called a semantic error. It is known as a logic error, which occurs when the code is here the code is syntactically correct. Here I have defined it well, and I have a colon, and I have a proper indentation. Then I am calling this divide, and I'm storing it in the result, and then I'm printing the result. Syntactically, it is correct. But when you execute, you're going to face some error. It is telling division by zero is not allowed. You cannot divide any number by zero. It cannot, because there is no such operation as dividing by zero. We cannot give any result, right? So it is called semantic error
Logical
because,
error. Is it logical
sorry?
error? Is it
Yeah,
logical
logic
error?
error. Yeah,
Okay.
semantic error is nothing but logic error. Logically, it is failing, but syntactically, it is correct. When you have defined everything, syntax wise, everything, whatever you have written is correct. But syntax error is what you have seen. You are missing something. You're not following the rules of Python language. You're not following the language at all. Here it was expected, but we are not giving. Okay. So similarly, we have compile time and runtime error. We saw what is semantic and syntax. Now we'll see what is compile and runtime. Compile time and runtime are two distinct phases in life cycle of a computer program. They refer to different stages of program execution. Okay. Compile time refers to the phase when a program source code is translated into machine code. During the compilation, what happens? The source code, whatever you are writing here, which is in understandable by the human, is translated into machine code. or intermediate code by a compiler. So machine code will have zeros and ones. So you will not understand anything. Human cannot understand that. It will make translate so that the computer now understand. During compile time, what happened? Compiler checks all the syntax and translate it to a computer's which can be understand by computer's processor. Okay. While translating, if it sees something which it itself cannot understand because there is an error. It doesn't know where this string is started with here h and it doesn't know where it is ending. So it is not understanding beyond this line. This line it does not understanding. So then it will throw an error directly while translating it to a machine language itself. So the common task during compile time is syntax checking, type checking, generating an executable code. Okay. The output of a compile time process is usually an executable file or bytecode, which a computer will now run. Okay. So it will translate it to a bytecode. When all the syntax are good, it will directly translate it to bytecode without throwing any error. Now you can execute it. You can run it. Okay. During runtime is also known as execution time or dynamic time. It is a phase when the compiled program, which is already compiled, will now be executed by the computer's processor. During runtime, the program instructions are processed like data manipulation, like storing a variable data into a memory and then updating it. All those things will happen during runtime, which will not happen during compile time. Okay, allocating a memory and then getting an input from the user dynamically, you will change the values. So this all happens during runtime. Runtime is dynamic and compile time is static. It will not change anything in the program, but runtime will change all the data inside it, will handle all the data, update and delete the data based on the user input. Okay. And error and exception that occur during runtime are known as runtime error or exceptions. Okay. What they do, they cause the program to terminate abnormally. It will not tell ex- during compile time, it also terminate whenever it sees some error. But it clearly defines what is the issue, what is the error, and why it is not successfully compiling it. So here you will know it not successfully compiled. You have to fix something and where it is, line number, the error name and the description is given. But runtime, you have to take care of it. Unless until you mention, you handle the exception, it will not throw any error, but it will abnormally, it will exit. You will not know where it is failing, till what line it executed. It will be really confusing when you do not have the exception handling. Okay. So we will see few built-in error because this is one of the very common interview question. We have few built-in exception. One is syntax error, another is type error, another is name error, and we have index error. We have seen all these error in the past. So index error is nothing but when you give index out of range, you will see index error, right? Let me show. So when you have a list, you're trying to access index 3. We do not have index 3. We have 0, 1, 2 only. So it is going to give me index error. Index error, the list index is out of range. So we have similarly key and value error. Key error is when we face in dictionary, and value error also we will face in dictionary. And here we have seen the zero division error. Here we have seen syntax error, the first one error. And we also have import error. This exception is raised when when you're not importing statement properly, when you're not loading a module properly, but you're trying to use a particular function inside it. Okay. So these are the different errors types we have in Python. So for example, if your code is having hundreds of line, okay, and you have error, you have syntax or name error or any kind of error, you have 4 to 5 errors in that line. Okay, different line is having different error. So when you run that particular program, will all the error will be shown in one single go? Like you have 5 different error, you have to fix all this. Like, will that be given by the program when you execute it?
Come again one more time. I will.
Yeah. So if you have 10 lines in your program and
Mhm.
you have error in line number 5, line number 6, and line number 7, you have error in all 3 lines, 5, 6, and 7. Okay. Now we
Mhm.
are executing it. When you execute, will all 3 error will be shown in one single go? The 5, 6, and 7.
I think one by one we have to. So
Sorry,
one by one it will through.
it will throw one by one. It will throw in one single go. Like
No, it's a
one by
since
one
it
means
is
I didn't get.
compiling, so it will be getting first whatever the first error it encounter. I suppose this
So
is
what happens is whenever it compiles, it will whenever it sees the first error, it will stop there. It will throw an error to you so that the user can, the programmer can understand. It will stop the execution. It will not go and see the remaining lines in the code. So when you are first time, you will see only the error of line number 5, what that particular error is. When you fix it, now the line number 5 will get executed. Now it will fail again at line number 6. So it will show only one error at the time because the remaining error are uncovered because it not traversed to the remaining lines of your code. When it saw a error, it stopped there and it threw error. So that's when what happened when we debug something. In it will you will fix one error, but you will face another error. It will go on until all your lines are error free. So this is called debug session. We do that, right? We debug it. Debugging is nothing but your program is not working. You have to fix it. There might be multiple error. You have to fix one after another. So we have these keywords in Python program to handle the exception during the runtime. So we have seen during the compile time, it will have these inbuilt exception it will throw to us. But during the runtime, whenever there is an issue, you have to raise your own error in your you have to handle your exception in your code so that you understand why the program is not running properly. Okay. So how do you handle? You have to write a piece of code for it, right? So that you do using try, except, finally, and tries. So let's see an example.
in this try accept finally. And what is raise actually? Because I never heard
Raise
of.
a shoe, raise an exception.
Oh,
But raise is not frequently used. Let's see. Yeah. Try, except alone is fine. With this only you can handle your exception. If needed, you need finally, and sometime you will need rise. So here I'm just getting input from the user. Let me run this. I'll not know what the user might give, right? He can give 1 or he can give 0. But here we are doing division. whatever he gives will be the divider. Okay, so here I'm giving 0. So now it is showing the 0 division error. Okay, so what will happen next time when I give A? It is going to give me the value error because you cannot divide 10 by A, right? And so this is all the error we might face. So what I'll do, first I will put my logic inside try. Okay, whatever logic I have. Now I'm going to handle the exception. Okay, first I'll be handling 0 division error. So I will tell whenever you see 0 division error, whenever you face this error, just print this. 0 division cannot be done by 0. Then when you face value error, print this, enter a valid number. Okay. So I'm telling when you face this error, I'm going to print a different message to the user. So here instead of telling invalid literal and all, I'm just telling please enter a valid number. You are not entered a number at all, right? Here you have entered a string, a character. Now, these are the known exception I might expect. So I know whenever there is a division, when I'm getting the divider, there might be two cases. He might not give a valid number, he might give 0. Even it's a valid number, 0 division is not allowed. So some other exception can also happen, which I cannot forecast now. I do not know. But what I can do, any other type of exception, except exception as E. Any exception you see, when you know the exception type category, you handle it directly. When you do not know, you are telling except exception as E, and then you tell some error. Okay, whatever error it found. For example, if it like 0 division value, maybe if it had found some key error or value error, any error, what it would tell, it will tell print that exception error message here. Okay, what you are handling that particular exception E, you are printing it to the user so that the user will understand, the programmer will understand what this error is. Clear?
Yes, miss.
So instead of just writing this piece, I'm just putting it inside the try and I'm doing all the exception. I need not have these as well. I can just put whatever exception you see, handle it, you just print it instead of abruptly stopping the program, enter this. Okay, and in case if I do not see any exception, this is when I see exception. In case if I do not see any exception, else
Report result.
print the result.
So,
Clear?
okay.
uh Guys, I'm actually couldn't talk. I have throat pain, I got cold. Shall we end our session here? We will continue tomorrow.
Okay, ma'am. Take care, ma'am.
Yeah,
Sure.
so we have seen one simple example of exception. We will see in depth like how to use finally and rise our own exception tomorrow. Okay.
Okay.
Okay. Thank you guys.
Thank you.
Bye.
Thank you. Bye, ma'am.
Yeah, thank you.